It really hits you sometimes, doesn't it?
What's that?
Just how much our physical well-being is now linked to the digital world.
Oh, absolutely. Yeah.
I saw this statistic. It almost feels like sci-fi. So many of us using wearables, tracking steps, sleep, everything.
Constantly feeding data.
Exactly. Our body's just pumping data into the digital space. And, well, that's pretty much what we're diving into today.
Right.
This whole fascinating overlap. We want to give you the essentials, without drowning you in jargon.
Exactly. And we're looking at something specifically called biodigital convergence.
Okay.
It might sound futuristic, maybe, but it's actually a concept that's been brewing for, 20 years now.
20 years, really?
Think of it as like the meeting point, the coming together of fields like engineering, nanotech, biotech, IT, and even cognitive science, our understanding of the brain, all working together in ways that are, mutually beneficial.
Okay, biodigital convergence. Let's break that down a bit more. It sounds impressive. What's the core idea there?
Well, at its heart, it's often described as a creative union of what people sometimes call MBIC technologies. So that's nano, bio, info, cogno.
Got it, NBIC.
Yeah. Nanoscience, biotech, IT, cognitive science. The original thinking, this goes back to around, say, 2000, was that this kind of synergy, putting them all together, could really push the boundaries of, well, human performance.
Push the boundaries.
Yeah.
Okay. That's still quite broad, though. Can you give me some, concrete examples of how these fields are actually merging?
Sure, absolutely. We see it happening in quite a few ways.
Okay.
So take biotechnology, things like bioinformatics, genetic engineering, genomics. They now lean heavily on the data analysis power from IT.
Makes sense. The sheer amount of data.
Exactly. And then you've got ICT, information and communication tech itself. Areas like computational biology are directly modeling biological systems.
Right.
And over in nanotechnology, we're seeing things like biosensors, bioelectronics, tiny physical devices, right? Designed specifically to interact with our biology and then send that data, well, into the digital world.
Biosensors. So we're talking more than just the ones in our smartwatches.
Yeah, those are a familiar example, definitely, but the scope is way wider.
Okay.
This convergence is enabling some really groundbreaking stuff in health and medicine.
Like what?
Well, think about human augmentation.
Right.
Things like exoskeletons helping people walk again, or really sophisticated bionic implants.
Wow.
And we're also seeing advanced biomedical tools like organs on a chip.
Organs on a chip?
Yeah, they're used for drug testing, saves using animals sometimes, even things like tracking how diseases spread.
Epidemiology.
Exactly. Sensor-based epidemiology. It relies completely on this interconnectedness. And of course, the big one, personalized medicine.
Tailoring treatment to the individual.
Precisely. Based on their unique biology, often using really complex digital models. That's a key outcome.
Okay, that gives us a really good sense of the bigger picture. So biodigital convergence is kind of the foundation.
Yeah, the framework.
And now we're zooming in on some specific tech within that. The sources mentioned IoT and digital twins for healthcare?
Exactly right. The Internet of Things, IoT, provides a really crucial infrastructure for a lot of these biodigital health applications.
Okay.
The official ISO-IS definition describes it as basically a network.
A network of
interconnected things, devices, people, systems, data resources that can react to info from both the physical and the digital worlds.
Okay, so definitely more than just my smart toaster talking to my fridge.
Yeah. Bit more involved than that.
How does this IoT concept apply specifically to health then?
Well, in healthcare, you often hear it called the Internet of Medical Things, or IOMT.
IOMT, right.
Or just smart healthcare. IoT is really a key enabler here. It depends on a whole bunch of other technologies like networking, cloud, big data, AI. And importantly, digital twins, which we'll get to.
Okay.
What's interesting is that these IoT systems are, well, they're very data-heavy, data-driven, and they're built around networks.
Right.
They can be pretty simple, maybe just one sensor, or incredibly complex, like cyber-physical systems running across a whole hospital.
And all this data that's so crucial, where's it actually coming from?
Primarily, sensors. That includes the ones we know, like in wearables, but also really specialized biosensors detecting biological signals, and even something called virtual sensors.
Virtual sensors. What are those?
They're quite clever, actually. They use data from sensors you do have to estimate something you can't directly measure. Like maybe your wearable uses heart rate variability and activity to guess how fatigued you are.
Ah, I see. Inferring data.
Exactly.
Correct.
And there's some really exciting research using things like graphene-based sensors for even more advanced health monitoring, super sensitive.
Okay, so loads of data streaming in from all these sensors, real and virtual. What's the payoff? How does IoT actually improve healthcare?
The real power, I think, is its ability to help make decisions using both real-time and historical data.
So spotting trends, intervening earlier.
Precisely. Identifying patterns, allowing for proactive care. These systems bring together data processing, analytics, and, like I said, increasingly, digital twin tech.
Right.
You hear buzzwords like smart everything, smart cities. IOMT is basically applying that smart idea to health. It's this whole network, right? Connected medical devices, software, all talking securely, enabling remote patient monitoring, faster analysis of medical info. We're even seeing this convergence of IT, data-centric computing and OT, operational technology.
OT, like in factories?
Kind of, yeah.
Right.
OT manages the physical stuff, the equipment, the processes. In hospitals, that means vital sign monitors, infusion pumps, HVAC systems.
Ah, okay. Managing the hospital's physical operations tech.
Exactly. So IT and OT are coming together.
Yeah.
And a classic IOMT example is something like a wireless implantable medical device, like a pacemaker that sends data out.
Gotcha. Okay, so IoT is the network, the data flow. Now, let's get into these digital twins you mentioned. What exactly is a digital twin, especially in healthcare?
Okay, so the ISO AAC definition again. It describes a digital twin as a digital representation.
A digital copy.
Essentially, yeah. A digital representation of a real-world thing could be a patient, a specific medical device, maybe even a whole hospital system.
Okay.
And crucially, it has data connections. These connections allow the digital version and the physical version to stay synchronized.
So it's not just a static model, it's live.
Exactly. That's the key. It's not just a blueprint. It has the potential for connection, integration, analysis, simulation, visualization.
Wow, lots of capabilities.
Yeah, optimization, collaboration. It gives you this complete picture over the whole life cycle of whatever it's representing.
So it's like having a continuously updated virtual mirror of something real.
That's a great way to put it, yeah. A virtual mirror. Digital twins reflect physical objects, processes, even people. Using huge amounts of real-time data from sensors, those virtual ones too, transactions, other data feeds.
Okay.
And it's not just one-to-one. You can pull data from multiple digital twins together.
Aggregate the data.
Right. To get a broader view, like understanding the efficiency of an entire hospital network, not just one department.
What's the main advantage then? Why have this virtual mirror? What makes it so powerful?
The potential value is, well, it's immense. Digital twins are really key to that smart everything idea.
How so?
Because they offer deep insights into how things are performing in the real world.
Okay.
And those insights can lead to actual tangible actions, like refining the design of a medical device based on its twin's performance data, or streamlining how a hospital operates, or getting back to personalized medicine, tailoring a patient's treatment plan with much, much greater precision.
And the data feeding these twins, you mentioned some characteristics.
Ah, yeah. People often talk about the 5 V's of the data involved.
5 E's.
Volume, there's lots of it. Velocity, it comes in fast. Variety, it's different types of data. Veracity, it needs to be accurate. And value, it has to be useful.
Volume, velocity, variety, veracity, value.
Got it. And you specifically mentioned human digital twins for healthcare. What's the thinking there?
A human digital twin is basically a computer model of an individual patient.
Model of me.
Potentially, yeah. It brings together all your available data, your medical history, genetics, lifestyle info, real-time data from wearables, maybe,
Okay.
to create this personalized virtual representation of you.
That sounds incredibly powerful.
It really can be, especially for personalized medicine. It lets doctors simulate different treatments on your twin.
Simulate them first.
Exactly. See potential outcomes, potential side effects, before applying them to you, the actual patient.
Wow. That could be revolutionary.
It has that potential, but digital twins aren't just for individuals. They're being used for much broader things, too.
Like monitoring environmental changes, tracking pollution. There's even talk of a digital twin Earth for climate modeling and forecasting.
A twin of the whole planet. That's ambitious.
Very.
Yeah.
But it shows the scale of the concept.
Okay, this all sounds incredibly promising, maybe a little daunting, too. With all these connected technologies, vast amounts of sensitive data, How do we make sure it all works together safely and securely? Are people working on standardizing this stuff?
Oh, absolutely. Standardization is, well, it's essential. It's non-negotiable, really.
Right.
There's actually an international committee, part of ISO and IEC, called JTC 1SC41.
SC41.
Yeah. Their whole focus is developing standards for the Internet of Things and digital twin technologies.
That's kind of standards.
All sorts. Everything from the basic vocabulary, just making sure everyone uses the same terms,
Uh-huh.
to big picture things like reference architectures for IoT and for digital twins, and guidelines for specific use cases, too.
So, like blueprints and dictionaries for this whole ecosystem.
That's a good analogy, yeah. These standards are crucial, so different systems from different companies can actually work together, interoperability, and just for having a common understanding in such a complex area.
And you mentioned an interesting example earlier from Rwanda about how IT standards can really impact healthcare on the ground.
Yes, that's a great case study. The Rwanda Standards Board, the RSB, they have a technical committee, TC21, focused on IT and multimedia, and they're actively using IT standards to contribute to SDG 3, good health and well-being.
The Sustainable Development Goal.
Exactly. It ties into Rwanda's own national strategy, which really emphasizes using ICT to improve quality of life.
So what have they actually done? What standards?
Well, they've established national standards for things like information security management in healthcare.
Crucial.
Very. And even for things like an electronic cane for visually impaired people, it shows how IT standards can have very direct, tangible health applications.
That's a fantastic example of the real-world impact. What benefits have these standards brought to Rwanda's health sector overall?
Well, they've supported capacity building, for instance, in tackling HIV/AIDS. They've helped promote inclusion for people with disabilities.
Right.
They make things like telemedicine easier and improve access to reliable health information for everyone.
Sounds great. Any challenges?
Oh, sure, there are always challenges. Things like limited budgets, finding enough skilled people to implement and manage these systems, and just general awareness, making sure people understand why these standards are important and how to use them. It's an ongoing process.
Makes sense. Now, you also mentioned another ISO-IE committee, SC43, working on brain-computer interfaces. That sounds like something straight out of science fiction.
It does, doesn't it? And it is really cutting edge, advancing incredibly fast.
So brain-computer interfaces, BCIs.
Exactly, BCIs. This tech creates a direct link, a communication pathway between an external device and the human brain.
Wow. For control.
Control, yes, but also information exchange. SC43 is focused on creating the standards for these interfaces.
And the potential in healthcare.
Huge. Think about rehabilitation, helping someone control a robotic hand or a prosthetic limb just by thinking about it.
Incredible.
Or applications in digital medicine, maybe even education. But for this to become widespread,
You need standards.
you absolutely need standards. For wider adoption, making it more affordable, ensuring different BCI devices can work together, interoperability again, and crucially, addressing the ethical side.
Yes. Ethics must be huge here.
Paramount. SC43 is actively developing ethical guidelines, things like protecting user rights, privacy, ensuring safety, fairness.
What kind of guidelines?
They're looking at key pillars: autonomy and agency the users control, beneficence and non-maleficence doing good, avoiding harm, fairness and justice, accountability, social and environmental responsibility, and of course, privacy.
That sounds comprehensive. Is it hard to get global agreement on ethics like that?
It is challenging, definitely. Language differences, cultural variations, plus the technology itself is evolving so quickly. But it's vital work to build public trust.
Absolutely. Okay, one more area, cloud computing. You mentioned SC38.
Yes, JTC 1SC38 handles cloud computing and distributed platforms. They have a relatively new project, ISNP 2996,
And that's about?
Cloud Customer Business Continuity and Resilience.
Okay, so keeping things running when you use the cloud. Why is that specifically important now?
Well, it's always been important, but events like the COVID-19 pandemic really highlighted how much critical infrastructure, including healthcare, relies on cloud services.
Right. Everything moved online.
A lot did, yeah. And we need robust resilience. This new standard aims to give guidance specifically to the customers of cloud services.
The hospitals, the clinics.
Exactly. Guidance on how they can ensure their own operations stay resilient when they're dependent on those cloud providers.
Because it's a shared responsibility, right? Not just up to Google or Amazon.
Precisely. The shared responsibility model is key in the cloud. Traditional business continuity plans, written for when you ran everything in your own data center, don't always map perfectly.
Fills that gap.
That's the goal. To provide cloud-specific, cloud-native guidance that helps organizations use existing broader standards, like ISO 22301 for business continuity, effectively within their cloud environments.
We've really covered a huge amount today. It's fascinating how it all connects.
It really is.
Biodigital convergence as the big idea, then IoT and digital twins making it happen in healthcare.
Enabled by sensors, data, networks.
And all of it needing that crucial underpinning of standardization and increasingly ethical guidelines.
It's a very interconnected ecosystem, and for you listening, I really hope this deep dive has maybe sparked some aha moments.
Yeah,
Seeing the potential for healthcare that's much more personalized, more proactive, the power of remote monitoring, these new kinds of treatments becoming possible.
absolutely. And I think it's clear that understanding these things isn't just for tech experts anymore, is it?
Not at all.
It's relevant for anyone interested in where healthcare is going, professionally, or just because, well, it affects all of us eventually.
True. And there's always more to learn.
Sounds like exploring those standards committees' websites might be a good next step for anyone really curious.
Definitely. If you want to see the details of how this is being shaped, the ISO and IEC websites are the place to go.
Okay, so as we wrap up, here's maybe something to chew on.
Mm-hmm.
With all this amazing technological power converging in biodigital systems, how do we strike the right balance? How do we ensure these tools are used effectively, ethically?
And that the benefits are shared widely.
Exactly, while still protecting individual autonomy and privacy in this super connected future? It's a big question to think about.